Now we need to find at n equal to 2. So y of 2 is equal to sigma k ranges from minus infinity to infinity x of k into h of 2 minus k. So how you will draw h of 2 minus k? How you are going to draw h of 2 minus k, from which graph?
Sir, h of minus k we have to shift to the right by 2.
By 2, or else simply you can observe h of 1 minus k itself now. H of 1 minus k you can observe and shift it right side again by 1 unit. That also it is fine, right? Because otherwise some mistakes will be there. Careless mistakes would be. Okay. So what you have to do is you can observe h of 1 minus k and shift right by 1 unit. That will get you h of 2 minus k. So to draw h of 2 minus k, shift h of 1 minus k by 1 unit towards right. Clear? So that's how the graph will look like when you plot h of 2 minus k. You will be starting from -1 and ending at 1, 3. I hope this is correct. H of 2 minus k. And again you will redraw x of k. X of k is simply starting from 0 and ending with a 2, having the amplitude 1. So when you multiply and sum, the answer will be the common time instance. Again it is 0 to 2. The common time instance are 0 to 2. At 0 there it is having -1. So -1 into 1 plus at 1 you're having 2 and 1. So 2 into 1 plus at 2 you're having 3 and 1. So 3 into 1. So answer is -1 plus 2 plus 3. Answer is 4. Correct now? Did you got this answer y of 2 as 4?
Yes, sir.
Okay. Now go for n equal to 3. Vidya, you tell me how you can find y of 3. What is the equation to find y of 3?
Summation of k equals to negative infinity to positive infinity. X of k, h of minus k plus 3.
Yes. Very good. X of k into h of minus k plus 3. Because 3 minus k is minus k plus 3. So to draw h of minus k plus 3, what you have to do? Shift h of minus k plus 2 to right side by 1 unit. Already we have plotted h of minus k plus 2 in the previous case. So that you need to shift towards right. So that you will get h of minus k plus 3. So the signal will start from 0 and end with 4. One, minus 1, 2, 3, 1. Again, you will be plotting x of k. So when you multiply this, again the common time intervals are from 0 to 2. So at 0 you are having 1 and 1, so 1 into 1. At time t n equal to 1 you are having -1 and 1. At n equal to 2, you are having 2 and 1. So the answer is 1 minus 1 plus 2, that is equal to 2. Similarly, you find y of 4, y of 5. So y of 4 is equal to k varies from minus infinity to infinity x of k into h of 4 minus k. So plot h of 4 minus k by shifting h of 3 minus k towards right by 1 unit. So it will be starting from 1 and ending with 5. Starting from 1 and ending with 5. X of k is still the same, starting with 1 and ending with 2. The values are 1, 1, 1. Now, when you multiply this and add, the common signals that exist is from 1 and 2 only. These are the two instances of time where the signal exists, 1 and 2. At 1, you are having 1 and 1. At 2, you are having negative 1 and 1. What will be the answer? 0, right? Have you got the answer?
Sir, is it 0?
Yeah, 0. Any doubts? Now the
Sir, I
last,
connected just now. Sir, can you just explain how it became 0?
who is that speaking? May I know the name?
Sir, Nirmit Verma.
Nirmit, you joined now only, right?
Yes, sir, right now just.
No, I can't. Sorry. You just check the because late comers born. I can't permit to the class. You are always late. Okay. So just
No, sir.
go through the records.
Sir, right now means after 7 minutes I joined. Before I joined that.
See, h of 4 minus k is plotted. X of k is also plotted. Now you can observe these two figures, and the common time that is observed is 1 and 2. What are the two common times the signal exists? It is at 1 and 2. Here you don't have any signals at all. Here also 1. So 0 into 1, 0. Like that, time wise you multiply and add. Time wise you need to
Okay.
multiply and add. So the only
Okay,
the
sir.
two times that the signal is existing is at time 1 and time 2. Because when you see figure 2, that is x of k, there is no signals from 3, 4, 5. So that remains 0. So the signal is existing only from 1 and 2. So at 1 you are having 1 and 1. So 1 into 1 plus at time 2 in the first figure you are having negative 1, in the second figure you are having 1. So 1 into negative 1. So 1 minus 1 is 0. Hope that is clear for you. Any doubts?
Yes, sir. Now clear. Thank you, sir.
Okay. Now go for the last sequence y of 5 because you are there to plot the signals from negative 1 to 5 because the output samples are having the total length 7 and it is starting from minus 1. So minus 1, 0, 1, 2, 3, 4, 5. That will make 7 samples in the output, right? So this will be the last output that you are going to calculate. H of 5 minus k. So to plot h of 5 minus k, again you need to shift h of 4 minus k towards right side by 1 unit. So it should start from 2 and end with the 6, right? The same figure you are going to shift towards right side by 1 unit. So it will be starting from 2 and ending with 6. Starting from 2 and ending with 6. Whereas the signals at 0 and 1, it will be 0. You will plot x of k also. Now you will multiply and add. When you multiply, you can observe the only time instance. Nirmit, can you tell me which are the time instance that is commonly existing? Because I need to check whether you have understood or not. Which are the two time instance that exist common? Which are the time instance for the both the signals that is existing in a common way? 0 and 1. Do you have any signals in h of I minus k? 0 and 1. When you take 0 and 1, do you have any signals at h of I minus k?
No, sir.
No.
No, sir. No, sir.
So which is
No,
the
sir.
only
0
time
and 1,
that
it's
you
not
have?
there.
Tell me.
Sir, 0 and 1 in the first diagram there is no signal in 0 and 1.
Okay.
From and in the signal and in the next diagram the signal is starting from 1 and I mean the y axis is at 1 and the signal is starting from 1 2,
Okay.
but the amplitude is same in the second diagram.
Okay. So when you multiply, from which time you need to start? I'm asking. From which time? Which is the common time where both the signal is having the amplitude? Which is the common time where both the signal is having
1. Sir, it's 1.
No. At 1 you are not having any signals here. At 1 you don't have any signals in the first diagram.
Oh yeah, yes sir. It's 2 then. It's 2.
Yes, it is 2. So at 2 you
Yes,
are
sir.
having 1 and here 1. So answer is 1 into 1 equal to 1. Whereas when you go for 3, do we have any signals in the second graph? No. 4 also you don't have. 5 also you don't have. So the only common signal that exists in both the figure is at n equal to 2. I guess you cleared now.
Yes, sir.
1 into 1 equal to 1. So this is your final answer. Now after getting all the answers, now you list down all the answers from y of 0, y of negative 1 to y of 5. All of you. After getting all the answers, kindly list the answers from y of minus 1 till y of 5.
So we have to plot the graph now.
Yeah. So answers are 1, 6, 2, 1, 4. Sorry, y of minus 1 is what? Kindly tell me the answer. Y of 1 is? Y of 0 is 6, right?
Sir, y of 0 is 4, sir.
Yeah, y of 0 is 4. Fine. Okay, y of 1 is 6.
Yes, sir.
Is this correct?
Yes, sir.
Okay. Now you will plot the final figure. So at ending it will start from negative 1 to 6. So at negative 1 you are having 1. At 0 you are having 4. At 1 again you are having 6. At 2 it is correct. At 1 it is 6. 1 it is 6. At 1 it is 6. Then at 2 you are having 4. At 3 you are having 2. At 4 it is 0, so it remain at x-axis itself. At 5 you are having 1 again. So this is your graph that you will get. Okay, so you have just there to plot the signal. This is your output signal y of n. Now you can simply represent this discrete signal in a set manner. So inside the set you will be representing in amplitude 146, 4201. So whatever you have that amplitudes you will be representing in a inside a set. Okay. And in that set you need to show an arrow mark. The arrow mark indicates the signal at n equal to 0. So kindly tell me under which number you need to put the arrow mark. I repeat, the arrow mark indicates the signal at the time n equal to 0. So after writing this particular set, under which number you should put the arrow mark?
First 4.
Yes, because at n equal to 0, you are having the answer as 4. So you are putting the arrow mark at under 4. So this is a way of representing the output. Either you can draw the output as such, or you can draw in the form of set, or represent in the form of the set. But the thing is that when you observe the question, the given signal is in the form of equation, right? When you observe the question, input signal x of n is given in the form of equation. Take the first page of this particular problem. The input is in the form of an equation. So with regard to that, what you have to do is you need to represent the obtained output in form of equation. Okay, so how you are going to represent this in equation format? Now one of you can answer me. Suppose this is a signal that you have got. How you will call this signal, or how you will represent this particular signal in equation form? Don't write anything. I just want to tell you. Just want to tell me the answer. How you will represent this particular signal? This one. How you are going to represent this particular signal?
Sir, y of n is equal to x of n plus 1. Sorry, n plus 1.
No, it is at the origin. No? It is at the origin you are having 1. So what is that particular signal? Recall that elementary
of
signals.
n.
Elementary signals. At n equal to 0, you are having 1, which means
Sir,
that
unit impulse.
yes, it is a unit impulse signal. How will you represent that impulse signal? Impulse signal, how will you represent?
Del of n is equal to 1.
Okay, it is del of n, isn't it? It is del of n. Okay, so this can be called as del of n. Clear? Now, when the signal comes at -1, how should I call this? How should I call this? Same signal I'm plotting, but the signal is now at -1. So how should I call this?
Del of n minus 1.
No, it
Sir,
is
del
left
of n
shift.
plus 1.
Yeah, very good. Del of n plus 1. See, please don't
Yeah,
confuse
okay.
about the left shift and right shift. Okay, otherwise the whole subject will not work. Okay, if it is plus means you need to shift towards left. If it is minus means you need to shift towards right. But the case is just opposite for the time reversal case. If you are shifting after taking the time reversal, then it is opposite. So you have to by heart those 4 cases. So as of now, this is del of n plus 1. Now tell me what is this then? What is this then?
Minus of delta of n plus 1.
Very good. The amplitude has changed to -1. So you have that a negative sign. So minus del of n plus 1. Simply you are putting a negative sign. So it will become minus del of n plus 1 because the amplitude has come down from 1 to -1. So you have represented it as minus del of n plus 1. I hope this is clear for you. Now, based upon this concept, you are there to represent our obtained output y of n in the form of an equation. Okay. Now you write the equation, output equation. Y of n will become. Okay. First, what will be the signal at n equal to -1? Because your output is starting from -1, right? Shiva can tell me. Shiva, unmute and speak. How you will write a signal that is existing only at -1? You observe your output graph y of n. So how you will represent a signal, that is, you forget about these things. 0 to 5 you forget. You focus a signal only existing at -1 and tell me how you are going to represent that equation. Shiva, unmute and talk. If it is wrong also, it is okay, but you need to respond. Shruti? Yeah, Shiva, tell me.
N plus 1.
Yes.
Plus 1.
Yes, yes.
Delta.
Yes. Del of n plus 1. And the amplitude is 1. So you can put 1 into del of n plus 1. Isn't it? So this is a signal that I have represented over there. That is 1 into del of n plus 1. Clear? Amplitude is 1. So I put 1. So 1 into del of n plus 1. Now coming to the second sample, how you are representing. So plus, you have to put a plus over there. Now how you will represent the sample at n equal to 4? Shruti.
Sir, del of n plus 4.
No, amplitude is 4. No, amplitude is 4. How come then it will become del of n plus 4? Amplitude, where you will represent amplitude? Inside the bracket or outside the bracket?
Outside.
So 4 into and tell me where it is existing, where that particular signal is existing, at which
Zero,
time it is
sir.
existing.
0.
0. So if a sample existing at 0 means, how will you represent? Earlier I told you, an impulse signal, if it is existing at n equal to 0 only, how you will represent it as?
U of n, sir.
U of n means it is 0, 1, 2, 3 up to infinity. No. Only at n equal to 0 means it is called as del of n. You have no basics. You have to tell, you have to study the basics, fundamentals. First module fundamentals you have to study. So del of n is the impulse that is existing at n equal to 0 and its amplitude is 4. So you have to put 4 over there. So 4 into del of n plus, coming to the next one. Coming to the next sample that is existing at n equal to 1. Sai Kiran can tell me, unmute and speak. Sai Kiran, how you are going to represent the sample that is existing at n equal to 1?
6 into del of n minus 1. Del of n minus 1.
Yes, 6 into del of n minus 1. 6 into del of n minus 1, correct, because it has shifted towards right side by 1 unit and the amplitude is 6. Now tell me the next term. Supriya, tell me the next term.
Sir, 5 into del of n minus 2.
5. How come 5?
4,
Yeah,
4,
yeah.
sir.
Yes, good, very good. 4 into del of n minus 2. Thank you. Plus next term is 2 into del of n minus 3. Now, can you tell me the next term at n equal to 4? Geetanjali, tell me the next term at n equal to 4. Do you have any signal over there?
No, sir.
No, so you can leave that. 0 into anything is 0. So there is no need to represent the signal at n equal to 4. Now you just represent the signal at n equal to 5.
Sir, 1 into del of n.
Del of n minus 5. Don't tell me
minus
del of
5.
n. Yeah. Del of n is
Right.
something which exists only at n equal to 0. Students, please be aware about that term, a del of n. Del of n is something which is existing only at n equal to 0. If that sample is existing at 5, means we have shifted towards right side by 5. So it will be del of n minus 5. And amplitude is 1. Okay. So if there is amplitude is 1, means no need to represent that. So I can omit that one from the first term and last term. If the amplitude is 1, means no need to show that. So this is the way of representing your y of n, your output equation in the form of equation. So you have 3 ways of representing your output in terms of graph, in terms of set, and in terms of equation. I hope you understood this. Any doubts, please ask. Otherwise, I will be moving to the next question. Can I? This is interesting, no? But the only thing is, be careful while multiplying and adding, because if you put a negative sign instead of positive sign or positive instead of negative, everything will get wrong.
Sir,
Yeah.
sir, one question. Sir,
Tell
what
me.
happened at fourth position?
Yeah, fourth position, this is in x-axis itself, right?
Yes, sir.
Means it is 0.
Yes.
So 0 into del of n minus 4 is 0, right?
Yes, yes, sir.
So I'm not
Okay,
going
sir.
to represent that. That's
Okay.
okay. Thank you. Now, next question, all of you write. A discrete time LTI system. Next question. A discrete time LTI system. Has impulse response h of n as shown in figure. Determine the system output. Determine the system output y of n if input x of n is given by input x of n is given by 2 del of n minus del of n minus 1. Take down the graph for h of n. So here both x of n and h of n is given to you. Both x of n and h of n is given to you, and you need to plot y of n. You are going to find the output signal y of n. But x of n is given in the form of equation. So you have to convert the given equation into graph. Lokesh M is there. Lokesh Biswas, you tell me how you are going to plot x of n.
So first 2 del of n. At 0 amplitude will be 2.
At 0 amplitude will be 2.
And minus del of n minus 1 at plus 1 amplitude will be minus 1.
Very good. So at plus 1 the amplitude will be negative 1. Because Del of n is shifted towards right, that is del of n minus 1, amplitude is -1. Here you have minus sign, means amplitude is -1. So I have shifted the graph downwards. So amplitude is -1 at n equal to 1. So this is the graph that you can draw after observing the given question. So this is not given actually. I mean, the graph is not given. It is a solution. Okay, so from the given question, you need to plot x of n. Because you are having two terms. One term is 2 del of n. You know what is del of n? Del of n is a sample which is existing only at n equal to 0. Its amplitude will be 2 as given in the question. But when you come to the second term, it is del of n minus 1. Del of n minus 1 is something which you have shifted towards right side by 1 unit. So that signal should exist at n equal to 1 and its amplitude is -1 as given in the question. So I have plotted the sample downwards with an amplitude -1. I hope this is clear for you. So as of now, you have x of n with you and h of n with you. Now tell me what is L and M. Tell me what is
2
L
and
and
5.
M.
Sir, 2 and 5.
L is 2, M is 5. How did you got this? L is the length of x of n. You are having only 2 samples now. This is one sample, this is second sample. Only 2 samples in x of n, therefore L you have taken as 2. While observing h of n, you are having 5 samples starting from -1 and 3. -1, 0, 1, 2, 3. Totally you are having 5 samples. So you put m equal to 5. So totally the length of y of n should be, length of output y of n should be L plus m minus 1. That is 2 plus 5 minus 1, 6. Correct? Now what is N1 and N2? What is N1 and N2? I told you N1 is the starting time instant of x of n and N2 is the starting time instant of h of n. So you have to observe x of n and h of n and tell me what is N1 and N2. Rutesh, tell me what is N1 and N2.
Sir, N1 is 2, sir.
Starting time, yaar. Starting time, not starting
Okay,
amplitude.
okay.
Starting time.
Okay, sir.
Yeah.
0, sir.
0. N2?
N2 is -1.
Very good. N1 is 0, N2 is -1.
Okay, sir.
So N1 plus N2 is -1. Therefore, the output y of n starts from -1 and ends at, totally you are having 6 samples at the output as per the theory, L plus m minus 1 theory. When you start from -1, at which time it gets end?
Sir, 4.
Yes. So it will start from -1 and ends at 4. So you need to get the output from y of -1, y of 0, y of 1, y of 2, y of 3 and y of 4. So all these you need to calculate. Calculating this, first I will be plotting x of k, let it be figure number 1. Then I will be plotting h of k, let it be figure number 2. Then I will be plotting h of minus k, let it be figure number 3. So students, all of you plot these 3 graphs. So to plot x of k, the same graph whatever you have plotted in the previous slide, you need to copy here. Just you need to replace that n with the k, that's all. X-axis you are plotting k. So this is your x of k. Similarly, h of n is also given in the question. This is given. H of n is given in the question. You have to plot h of k by replacing n with k. What is that? 1, 3, 2, minus 1, 1. 1, 3, 2, minus 1. 1, 3, 2, 1, 3, 2, minus 1. So this is your h of k. Then you need to plot h of minus k. Sachin, tell me how you are going to plot h of minus k. Sachin, unmute and speak.
Yes, sir. Sir, we'll have amplitude of 2 at minus 1.
Okay. 0, it will be remain 3. So you're having amplitude of 2
Yes,
at
sir.
minus 1. Okay. Then tell me.
Minus 1 and minus 1 at minus 2.
Minus 1. Okay.
Amplitude and amplitude of 1 at minus 3.
Minus 1 at minus 2. Then 1 at minus 3.
Minus 3 and 1 at 1, sir.
Okay. Thank you. Minus 1. So this is your h of minus k. Okay, now write the output equation y of n, convolution equation. Y of n is nothing but x of n convolution h of n. X of n is your input and h of n is your impulse response. As per the theory, y of n is nothing but the weighted sum of shifted impulse response. X of k is your weight and h of n minus k is your shifted impulse response. I told you we need to start from minus 1 and end at 4. So first we will find the output at minus 1. So the equation will become x of k into h of minus 1 minus k, or x of k into h of minus k minus 1. H of minus 1 minus k is h of minus k minus 1. So what is the graph that you need to plot in order to find y of minus 1? Harshit Gowda, what is the graph that you need to plot to find y of minus 1? As per the given equation, which graph you need to plot?
H of minus 1 minus k, sir.
Yes. H of minus 1 minus k, otherwise h of minus k minus 1. H of minus 1 minus k same as that of h of minus k minus 1. So you have to plot h of minus k minus 1. So to plot h of minus k minus 1, what you need to do? Plot h of minus k minus 1. You need to shift h of minus k towards left by 1 unit. Already you have plotted h of minus k in figure 3. So when you shift that towards left, it will start from minus 4 and end with 0. It will start from minus 4 and end with the 0.